So we'll have a look at some trig equations. Trig equations are a lot about just the process and getting organized and making sure that everything's good to go, more than being good at maths or being good at numbers. It's just about following, I guess, the right steps and making sure that the answers come out in the end. So we've got 6 steps to get through. The first step is making sure your equation is actually in the correct format, so it's actually ready to be solved. So we've got one here that is and two here that aren't. When an equation is ready to be solved, it's just got a sin or a cos or a tan x by itself, and then a value on the other side, a number on the other side. So um, this is good. It's right to go because it's just got sin x by itself, and on the other side we've got a half. That's fine. What you'll get though is you'll get questions that look like this, where we've got a cos with a 2x. This 2 is going to stay. We deal with that later. But the problem is we've got this value here and this value here. So it's not actually ready to be solved yet or to be thought about as an equation that can be solved. So all we've got to do is we've got to move these values to the other side. And the steps are always the same. If there's a plus or a minus, you'll undo that first. And if there's a times or a divide, you'll undo that next. So I guess in 2 steps, we'd be leaving that 2 there for a start. We'd be subtracting the root 3 to the other side. And then that 2, being a timesy 2, can be divided on the next step. And that gets us to, I guess, our happy place where we've just got cos 2x by itself. And on the other side, we've got negative root 3 on top of 2. And that's good to go. A special case, and one that often pops up in assessments, is having sin x on one side and cos x on the other side. That's no good. Just if you forget how to deal with this, the technique is to divide both sides. And what we do is we divide both sides by cos x. This is just what you do when you see one that looks like this. The effect that that has is different for each side. On the right-hand side, I'm dividing something by itself. It makes 1. And on this side, this is one of our trig identities, that sin divided by cos actually equals tan. So we're turning a sin and a cos into a tan. And then we've got a tan x by itself, and it's ready to go, right? So these equations are now ready to actually be solved. Step 2, the thing that we worry about next is the domain, because trig goes forever. Trig equations go forever unless otherwise specified. So we don't want infinity answers. We just want answers from a set domain. So every question will come with a given domain or ask for a certain number of answers. So in this one, the domain is fine. It's saying that we're going to go from 0 to 4 pi, which means, if you remember our unit circle, that we're going to be spinning around, finding solutions from 2 different laps. Okay, so that one's good to go. It doesn't need to be adjusted. The 2x, this is now where we worry about that, because it changes our domain, because we're technically rotating twice as fast around our unit circle. So what we just do is we apply that 2 to the domain. So we times, since the x is being multiplied by 2, the endpoints of the domain need to be multiplied by 2 as well. So this is not a domain from negative pi to pi. It's a domain from negative 2 pi up to 2 pi. So what that means for us, we will be doing a lap of our unit circle and getting 2 answers from it, because that's this part of it here. This part of the domain here actually says we're going to hang a 2 pi backwards. So we're going to do a whole lap backwards and get 2 answers there. So both of these will have 4 solutions. And it's because I've adjusted this domain, because there's a 2x there and not just an x. So these next 2 steps are the 2 most fundamental, I guess, to solving, because they're the 2 that show your best understanding of what's going on with trig equations and with your positives and your negatives here and just knowing your unit circle. The first thing you've got to do is find your exact value. We've been calling it our reference angle. All right, so we're going to write that down underneath. We're still just getting organized. We're not solving yet. We're just organizing our thoughts. So we're going to reference a table of values, which will be in your bound reference or your glossary, where we've got lots of numbers that look like halves or root 2's on 2's or root 3's on 2's, and figure out what angle or what radian measure actually goes with it. So with this one here, this is actually a 30-degree angle. That's what your table will tell you. You'll go to the sin column, the sine column, and you'll find a half in it, and it'll be in the 30-degree section, but more importantly, it's pi on 6. And if you do the same thing with this one, you go to the cosine section, the cos section, and you find root 3 on 2. Doesn't matter that there's a negative there yet. Root 3 on 2 actually has the same reference angle. It's actually pi on 6. All right, we don't care that it's 30 degrees. That's just there, in your table, pi on 6 is what we're going to be working with. So both of these questions, the solutions are going to be referencing pi on 6s. Then in terms of finding the correct quadrants, that's where we worry about positives and negatives. Right, so we've practiced this mnemonic, ASTC, where everything is positive, sine is positive, tangent is positive, and cosine is positive. And we need to highlight where our answers are actually going to be. So this is sin, it's positive, so there's going to be an answer in this quadrant, because everything is positive in this quadrant. There's going to be an answer in this quadrant, because this is where sin is positive. For this example, I'm working with cosine, and I'm working with a negative value. So I want to know where cosine is negative. So it's positive here and it's positive there. So cosine is going to be negative here, right? Because that's where only the s is positive. So c isn't. And here. So the solutions to this equation are going to be in these quadrants. The solution to this equation are going to be in these quadrants. And it's the combination of this and these that are going to give us our solutions. All right, now we're fully organized. We're ready to actually find those answers. We can put everything we've, I guess, thought about together. It looks a bit busy, but generally, if an equation's nice and easy, like this first one, sine x equals a half, all we've had to really do is look at our table, find the pi on 6. We've marked down these two quadrants, and then we're ready to start rotating laps around our unit circle. The domain and this will be written up here, and we've just written this down as part of our working out to get working out marks. So we're now solving for x, because we've got organized. So generally what we're doing, we're starting at 0 degrees or 0 radians, and we're spinning around and picking out the pi on 6 version of the answer in each quadrant. So if your answer's in the first quadrant, it's easy, because all you have to do is rotate pi on 6. The next answer has to be in this quadrant, and generally the way we think about it is we think about how close the answer is to the x-axis. So it's kind of what we did here. We started at 0, we went up pi on 6. We know that this value over here is pi, because it's half of a full rotation. The 180 degrees is pi, and we know that there is a pi on 6 gap here. Okay, so what I'm actually doing is I'm going to pi, and I'm going backwards pi on 6, because that's my reference angle. So I've got to think about what pi, take away pi on 6 is. And of course, because we're working with sixths, we think about pi as being 6/6. So we're 6/6, and we're coming back 1. So this solution is 5/6 of a pi. All right, and those are my two answers. But that's only from my first lap. This question says I've got to go up to 4 pi. So there's going to be answers from 1 lap. There's going to be answers from 2 laps. Okay, so when I get back to the start, I'm at 2 pi. And my next solution, it's in the same spot as it was the first time around. So we've just got to locate this again in terms of its sixths. So I'm at 2 pi and I'm a sixth more. So 2 pi's is 12 pieces. And then a sixth more would give me a 13th piece. But there is a shortcut. You don't have to actually think about it like that. Because we know the solutions are in the same spot, we can actually just add 2 pi to each of our first solutions to make the second one. That's quicker than, I guess, conceptualizing it in terms of rotating around the unit circle. Because we're working with sixths, 2 pi again is 12 pieces. So I don't even think too much about it. I add 12 pieces to each one. So this was 1/6 plus 12 pieces is 13. This was 5/6. So I add 12 pieces and I get 17. Now this question is finished, and these are the solutions, and it's done. This one's going to take a couple more steps. The thing that's different about this second one is that 2x again. Right? It's not just x we're solving for, it's 2x at this point. So starting off, we actually need to say we're not solving x, we're solving 2x. We are going to rotate around as usual. We do have negative rotations as well as positive rotations. So this one's got everything. Right? This one's as tough as it can get in terms of our current course. So we'll find the positive solutions first, which means we're starting at 0, we're rotating around, and this is the same quadrant as before, and it's the same reference angle as before. So the answer for a start is going to be 5 pi on 6. But of course, the way we did that is this was pi, which is in this case 6 pieces because it's sixths, and it was come back 1. In the next quadrant, I'm still worried about pi because pi is the x-axis, and I'm going forwards this time, right? So in this quadrant here, it was pi come back a sixth. This one is pi go forward a sixth. So it's going to be 6/6 and one more. Okay, so those are the two solutions I get from my positive lap, right? I just had to do one lap. I had to go up to 2 pi. I have to go backwards. So that's a bit different, a bit trickier. We have to rotate backwards to 2 pi, backwards a lap. So we go back to 0. And being that we're in these quadrants, we should worry about this value here. So if I'm rotating this way, I'm actually rotating to negative pi, right? Which is negative 6/6. So if I'm at negative 6/6, then rotating back further back would be negative 7/6. Getting back a bit closer to 0 by one piece from negative 6/6 would be negative 7/6. Oh, sorry, negative 5/6. This one was negative 7/6. This one's negative 5/6. It's all because they're just a sixth away from minus 6 pieces. That's the main thing to think about. But I talked about this shortcut over here that I could just add 12 pieces as I go. Since I was hanging a full lap backwards, and the answers are in the same spot as my positive answers, I could actually just take away those 12 pieces that I added over here. Right, 5 pieces, take away 12 pieces. Remember, we're taking away 12 pieces because it's 2 pi, and pi is in sixths, right? So 12/6. So 5 take away 12 is minus 7. 7 take away 12 is minus 5. So I actually could have done that, but it's important to know how to rotate backwards as well. Now we have one more step to go with this, because we've solved for 2x, not x. Okay, this one's done. X equals this, 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 and this. But in any equation we're solving for x, we're not solving for 2x. So we have to adjust our answer for these different values of x. Right? We know that if my x is being multiplied by 2, the correct approach is to divide by 2. So I'm going to divide everything here by 2. It's not going to change too much. Just going to change that denominator. So instead of being 5 pi on 6, it's now 5 pi on 12. Because that's half as much, right? 12ths are half the size of sixths. There's my two positive answers, 5 pi on 12, 7 pi on 12. Should actually do the thing you say you're going to do. And my two negative answers were negative 7 pi on 12 and negative 5 pi on 12. So that's the whole process from start to finish. Questions can be very simple and just look like this at the start, and that means you're just ready to go, ready to solve, and there's no extra working out to do. This one's kind of got everything in it, right? We have to rearrange the whole thing. We have to fix the domain, so we have to rotate further. Both questions just required us to simply find the reference angle from a table of values that's in your glossary to figure out the positive and negative quadrants. Then we rotate and identify those answers. And then if you have to, if you're solving for 2x and not just x, you just divide by 2 or something like that. Hopefully that's helpful.